Welcome to Natural Habitat Adventures Daily Dose of Nature, Pages of Stone, How the American Southwest Was Formed, presented by Dr. Court Whelan. Court is NatHab's Director of Sustainability and Conservation Travel and has been guiding trips for us since 2013. It's a pleasure to have you with us today, Court. I'm going to hand things off to you.
Kendall, thank you very much, and happy holidays, folks. I hope everybody's enjoying a joyous, festive holiday season, wherever you might be in the country, in the world. Greetings from my home to yours. So yeah, this one is, I love talking about this stuff. I was just thinking, next to guiding our monarch butterfly trips and the amount of trips I've done of those throughout the last couple of decades, this region that we're going to be talking about today might be second in line in terms of the just sheer number of trips I've guided over the years. I love it. I'm immersed in it. I live very close to this area, so not only do I go to this place when I'm working and guiding trips, but this is my playground too. I love taking photos of it. You've probably seen a lot of presentations I've done on national park photography and canyons area photography. So a lot of photos you may have seen from that make their way into this presentation. Yeah, it's just a beautiful, spectacular part of our world. And I love this idea, this Pages of Stone. It's a little bit of a cheesy kind of title or idea, but it's really quite interesting when you think about what that means. These in this picture kind of illustrates that quite well. We'll see a lot more that are indicative of that Pages of Stone, but really like every layer of stone in these Colorado Plateau national parks and state parks and preserves, they tell a story about the world. They tell a story about the temperature of the ocean that once was over this area. They tell a story about what sort of critters lived in this time period, the atmospheric oxygen, the rough temperature, where in the world it was. And there's a lot of information, a lot of data that can be gleaned from this stone. We're not going to be going too heavy into that aspect of things, but we are going to be talking in a big general sense of essentially how this stuff got there and how it looks today, all the processes that got us to where we are in some of the most iconic national parks of this desert Southwest. So without further ado, we'll go into a few pretty photos because I just want to build the excitement, build the stoke as to why this is truly one of the most beautiful places in the planet. I've guided on all 7 continents for years, and I still think that my own metaphorical backyard, or collectively our North American viewers, our backyard in Utah, northern Arizona, it's honestly probably one of the most beautiful landscapes on Earth. We've got a beautiful sunrise in Bryce here. We're going to talk about how all those lovely magical hoodoos got to take their shape. We're going to be looking at the Narrows of Zion National Park and how these 2,000 to 3,000 foot tall walls of Jurassic sandstone got there, and more importantly, how they were eroded away by this tiny but not insignificant river. Talking about different sort of archways and formations and colors of stone. Really, this place is otherworldly. It's also, for any of my photographers out there, probably one of the best places, again, on the planet to photograph the night sky. It's like tippy top, especially Bryce Canyon and Northern Grand Canyon, like the best places on the planet to see the Milky Way, see the stars with your naked eye, and of course photograph them as well. Has a lot to do with like altitude and humidity, the fact that it's so dry, but the fact that you're relatively high up in altitude. So it's just spectacular. It is an otherworldly place, and it's just such a cool notion that really everything we're going to see today was carved by water in some way, shape, or form. We'll talk about the different forms of water and how that plays a part. I think it's absolutely fascinating. But just the amazing power of water to carve through, in many cases, miles of stone from what it used to be to what we see in this present day period. So these pages of stone we're talking about, kind of a metaphor, it's literal, but it's also sort of metaphoric, is just the layers of the sedimentation, the different colors, the different textures, the different compositions. We're gonna be talking about how that plays a part. So one thing that I love to talk about with my groups, especially as I'm on these trips, but I think something that really is worth talking about here today is just a big idea of the history of life on Earth. All of it. We're gonna talk about the entire history of life on Earth in a very short section here. But I think this is really interesting. So basically, very quickly, the Earth was formed about 4.6, 4.7 billion years ago. A billion years after that, roughly 3.5 billion years ago, we start to get like an atmosphere. We get like a magnetosphere, like a lot of the big things we take for granted. And then about a billion years ago, 1 billion, we see sort of relatively modern life start to appear. And so we're going from this right side is a millions of years ago. So we're right around here. And we enter this time known as the Cambrian, and this big event happened called the Cambrian Explosion at about 542 million years ago. And that's essentially the birth of like modern life as we know it. The things that we're used to seeing, they're not like the things that live in our backyard, but the things we're like, oh yeah, that I think that lived on Earth at one time. Before that, it was all just like small little amoebas and stuff that was just very, very rudimentary building blocks of life. But again, around 500 million years ago, so if there's anything to remember, that's the big Cambrian explosion. That's when life really, really began to flourish. And we get these, horseshoe crabs and isopods. And, during this, couple 100 million years, I say that frivolously, a couple 100 million years, a lot of stuff happened. The insects first appeared on Earth about 300 million years ago. A lot of the critters that made essentially the building blocks of oil today, the ferns and all the different animals that lived and died, these cycles that created this slurry of high energy detritus, basically, all happened around this time period. And then we get this thing called the Permian Extinction around 250 million years ago. And this is the extinction people don't know about usually. People often know about the big one when the dinosaurs left, but this one was actually quite a bit bigger, again, around this time period. And you may be wondering, why am I talking about the history of life on Earth when we're really talking about rocks and geology? Well, I'll get to that in a second. But basically, I want to break this down into a couple main periods and how it relates to the rocks that we see and walk on in this really cool area of the Earth. So we're entering the Mesozoic. This is kind of like the age of the dinosaurs. We're talking about a couple 100 million years, a little less, that they were around. A lot of cool things happened with Zion National Park. And then sort of modern era at about 65 million years ago, the dinosaurs left us. We think it's this big asteroid, and the climate change, et cetera, et cetera. So this is kind of more modern life, 65 million years in current. We start to see the age of the mammals, and of course then man and civilization happens at the very tippy top of all this. So where this pertains and how this relates to this area is that we're really looking at all the stuff we see in the Grand Canyon is this entire time period on the bottom, all this like 252 to 542 million years, like all the rocks, they are laid down in each of these eras and each of these periods. In fact, a lot of what we know about these eras are from rocks and geology. Then this is the age of Zion National Park, and this is sort of the age of the rocks for Bryce Canyon National Park. So it's really cool how like the three big times in the history of life on Earth we're talking about are very mirrored with what we see in each of these beautiful, glorious national parks. So let's kind of zoom in and zoom out a little bit. So if you wonder where this is, Colorado Plateau, we're looking at the kind of the classic southwest of the United States. This is the area that's enlarged. This area that's a little bit darker stain, kind of looks like a coffee stain on a table. This is known as the Colorado Plateau, and it's a really interesting concept. I could probably do like a whole lecture on nothing but this, but the basic gist is that the Earth is formed into about 13 more or less major tectonic plates. You get some small ones, you get some big ones, but they're all pretty major because of how they interact with one another. And so it's important to know this because this is how Earth was formed. This is how Earth continues to evolve and shape. And this has a lot to do with how the Southwest looks. But kind of going back to this slide for a second, this coffee stain, this Colorado Plateau, has always been sort of immune to tectonic action. So as these plates move and subduct and shape and form and mountains build and they erode and this and that, this little bubble just happened to always have, the belief is that there's some sort of massive craton or some massive rock way below the Earth's surface that's resisting any sort of major tectonic forces in this small little patch. So we'll, again, come a lot more to this later. So basically, a quick overview of plate tectonics, because again, this is sort of the building blocks of the presentation to understand how everything else works that you're going to see here in these three different national parks. So basically, you have these major plates, and they're always sort of moving around. I like to use the analogy that imagine Earth and the globe as being, a swimming pool that you have in your backyard, and it's full to the brim of like rafts and rubber duckies and inner tubes. You get the big rafts, you get the little rubber duckies here, you got some inner tubes. They're all different shapes and sizes, but they're chalked in there, like they're all touching one another and touching the sides of the pool. It doesn't really matter if you go in there and move that inner tube. Everything else is going to move around with it because it's relatively frictionless underneath it. All these plates are sitting on top of magma, of the mantle. So these things can move and float freely. But something sort of interesting happens when the plates, especially oceanic plates, hit continental plates. And this is very typical. I'm going to talk about right here on the coast of California. It's very typical. What you have is you have one plate, and if you can see my webcam right now, you have one plate, my left hand, or maybe it looks like my right hand to you. But anyway, this one I'm moving will subduct underneath the North American plate, And then this rock that's actually underneath the ocean joins the magma and joins the mantle, as you can see here in this image. And basically that injection of rock, it's kind of like adding a bar of chocolate into like an already melted chocolate boil that you have going on the stove, is it joins that pretty quickly. And that creates more magma, more mantle. It creates pressure and buildup, and that's usually how volcanoes are formed and mountains are building. All mountain building events work more or less under those principles. The Andes, the Alps, the Rocky Mountains, they're a lot shallower, so they went way into the interior of North America, but all pretty much the same. The interesting thing, and this is sort of like the big next aha moment, is that none of that happened. Like when we think about the big, amazing landscapes of the world, the Alps, the Andes, the Alaska range, you know, big mountains. That is not how these formed. It was quite different. It's more about a big story about how all this sediment, how all this rock was laid down in the first place, and then how did it erode away to create the forms that we see in present day. So that's basically it. I'll say that again because it's quite important. So none of this was built. What happened is that all this sediment, every single grain of sand and clay and mud and granite was laid down basically, and then it was eroded away by some force. Very interesting. So what we often refer to this general area as in the Colorado Plateau is the Grand Staircase. Now there is a place called the Grand Staircase Escalante National Monument, and that's within the Grand Staircase, but technically the Grand Staircase, what you usually refer to, is fairly different. It's actually this cross section. We're looking more or less north to south. Right over here, we're looking at Bryce Canyon, and this is kind of like central Utah down south to southern Arizona. So if you think back to that that Colorado Plateau, we're kind of at that western top and bottom, the Grand Staircase. And this is where it's, you know, it's red rock country. It's where these national parks are. In fact, the Colorado Plateau in general is, I think it's the highest concentration of US national parks and monuments in the country outside of Washington, D.C. So it's chock full of all this. And what the real reason, well, it's not just beautiful, but it's so different from place to place. It's so different from a few miles this way, a few miles this way. And that's where the pages of stone come in. And that's where a few more pretty photos come in as well. So we're gonna be starting this journey off again on the left-hand side. I'll just circle it again with my mouse. We're starting in Bryce Canyon, which is the top of the staircase. What we're gonna do over the course of the rest of this presentation is work down the staircase, work down these layers of rock. These are these indeed pages of stone. We're gonna go down to Zion, and we're gonna go down to the Grand Canyon. There's a weird, you know, pretty interesting thing here with a little bit more uplift. So it's actually the height of Bryce. It kind of comes level in altitude, but nevertheless, it goes deeper and deeper and deeper into these pages of stone. And this is where, referring back to that history of life chart I was showing you, this is where, you know, these rocks that we're walking on predate the dinosaurs. The stuff that we're walking on formed before dinosaurs even took one breath on Earth. So really interesting stuff. Nevertheless, so let's start with the newest, let's start with the top. So this is the top of the staircase. Bryce Canyon National Park, a beautiful area. It's known for these amphitheaters, these hoodoos. It's only actually about 18 miles long. It goes north to south. It's this big cliff edge. So it's really interesting because of this topography, because of these hoodoos. Fun fact, you know, hoodoos, we don't really know what the etymology of that word is. There's not really a single ancient legend or oral tradition that we can pin that down to. It doesn't mean like temple, or doesn't mean capstone or anything like that. People just believe it was kind of a spooky sounding word from Native American cultures, sort of spooky, hoodoo, spooky, and that's kind of the best that you have. Now there, of course, are a lot of different actual folklores coming from this area. Things like these are the totems of ancestors, et cetera, et cetera. But in terms of the actual word, we still refer to it as hoodoo. It's kind of like a spire or a pinnacle. And what we're looking at here is the wonderful thing about Bryce is that when you pull right up to Bryce Canyon, you go out to the edge and you're looking at these massive amphitheaters and hoodoos all around you. So the photography is just stunning. It's really easy walking around the canyon rim, and you get all these different angles and different views and sunrise. Seeing it from an above aerial view gives you a whole different perspective. One of the things I love about geology is that a lot of what we see in present day erosion and deposition, like how geology works, how these things are formed, is really similar to like if you were just to see a sandcastle melting away in the sand near the shore, or how a mud puddle might form, and we'll get to that in a second. So it's kind of like a bigger sense of stuff we see in our backyard all the time, but when you see it on this scale, it's impressive. And on our expeditions, we actually do a quick helicopter flight top to bottom, north to south, to see this perspective, which I absolutely love. I think it's a real treat. But you know, as beautiful as it is from above, and as you know, how many photos you can get and see that perspective of that cliffside eroding, really one of the most special opportunities is to get down in the hoodoos. And you can see here one of our photographers taking a nice morning light shot, very soft, beautiful light. You can quickly see how different it gets as we descend some of these switchback trails down into the hoodoos, and what you thought might have been like little tiny pencils from above are actually massive, massive spires. I mean, this is like one hoodoo that you're seeing that's you know, right here encircling this person. So it's pretty spectacular, the size and the scope of this. You know, another perspective here, kind of going down these switchbacks, you know, these are hundreds and hundreds of feet tall. So how in the world do these things get here, and how do they take the shape of today? This is the interesting part. Beautiful part to start off with, interesting part here. So basically when we look back, you can see here the date in the bottom left-hand corner. We're looking at this bottom row here. We're gonna come back to that top row here in a second when we talk about Zion, but this bottom row, notice how as the earth formed and the tectonic plates moved and shifted all over the magma, all over the globe, right around 100 million years ago, we see this inland sea start to form. Actually, somewhere between these two, there is this relatively massive lake system that got isolated. So it started as a sea, it turned into a freshwater lake, and it turned into this little thing. It didn't even show up on that map really, but known as the Claron lake system. And so, like I was mentioning, so this happened around 30 to 50 million years ago, and this lake was isolated. Anytime you have water in marine environments, you basically have this cycle of birth and death. You have these organisms that flourish, especially in warm temperatures, and then they die, and they're basically their skeletons, their bones fall to the bottom in sedimentation. And you magnify or you fast forward that like millions, tens of millions of years, and you get a lot of sedimentation, life and birth, millions of years. And so what happens is as this lake system gradually dried up, as we get to closer present time, we go back to that analogy I made before, where it's kind of cool how a lot of these big cosmic things, especially in the desert and this red rock country, it's really similar to like if you were to look at a mud puddle in your backyard or walking down the street. It's really quite the same. So what happened is essentially this big lake system dried out, and the mud, which is that 35 million years of sedimentation, started to crack, just like you'd see something walking down the street, started to crack. This at one point, if we were to have a time machine and go back 35 million years, this entire, we're looking out at one of the amphitheaters, this entire area all the way to the Aquarius Plateau in the distance would essentially, in theory, be one flat mud flat. Like just we would have no idea the wonders that lurk below it, because it wouldn't be exposed until all that eroded away and all that below started to crack and crack and crack. So essentially, imagine this big mud flat. It started to crack and fragment just like any mud that dries out. It's just particle physics and particle science there. But all these cracks gradually started to get filled with water to the depth of like hundreds and hundreds of feet. And we enter one of the more unique ways of erosion in the Southwest desert area. It's known as frost wedging. So frost wedging happens basically when you have this ability for water to enter the cracks. It gets down in there, it freezes overnight. Believe it or not, Bryce Canyon sees about 200 nights a year that get below freezing. You wouldn't think so, but it's pretty high up there. It's 8,000 to 9,000 feet. So 200 nights, most of the winter is frozen. So what happens? Water gets down there, it freezes. When water freezes, what happens? It expands. It expands about 10%, and just the physics of water frozen starts to split that rock more and more, gradually more and more, all the way down hundreds and hundreds of feet. And what happens is as that splits, eventually it erodes off of this cliff face. So you have this cliff face here. I'm looking back towards, that's basically towards the west. And this cliff face is gradually making more and more hoodoos, new hoodoos, constantly. Now we're not going to see it in our lifetime. We're not going to see it in tens and hundreds of years. It's like thousands, tens of thousands, millions of years spectacle. But nevertheless, one of the most amazing things is that this cliffside is eroding from a geologic perspective, like pretty fast, 2 to 4 feet per century. That's pretty fast. I mean, 2 to 4 feet. I mean, in 100 years, they're going to have to like redo the park benches and the trails on this rim here because it is eroding fast. Now, we in real time never see anything fall. It's very, very static. It's not like glaciers calving, but nevertheless, that is the rate of erosion. So what we really see, again, going back to this aerial photo, is it's basically just a big mud flat that extended from the left of the screen all the way several times to the right of the screen. and it's exposing this dried mud crack underneath. It's really cool and really beautiful. So, you know, in a way, we are very fortunate, very blessed to see these shapes, these colors, these formations in our lifetime, because it's ephemeral. It does not last long. It's constantly retreating. Once these spires and these hoodoos get too weak, they fall off and they turn into dust and sand. They get eroded away, washed down the river, bada bing, bada boom. But today it kind of looks like this as we're walking along the hoodoos. You might think that it looks like sand. It's very, you know, gravelly and it's sloughing off constantly. It's not. It's lithified. It truly is rock. But then another thing kind of enters the equation here, and it's this idea of capstones, CAP capstones. And this is a great example here. We see this lighter color on top. It's what it does. It actually acts as an umbrella and protects the rock below. So these capstones aren't on every single hoodoo. They erode as well, but they erode at a much slower rate. And these actually have a little bit more magnesium in the composition. And so they are a little bit more resistant to rain, a little bit more resistant to the slight acidification that happens in the rain. And you'll notice that this layer of capstone that happened as one chapter in the history of time, when more magnesium was precipitating through this lake and this water, it's protecting these hoodoos to give them a very, very vertical feature. You'll notice as soon as this capstone wears away, they get much more of like a spire, like much more pointy. So yeah, it's kind of cool again, just to be at this exact moment in time that we're seeing these very, very, you know, 300-400 foot tall hoodoos in some cases. And you can see here another kind of sideways angle of this differential erosion, as it's called. This is a pretty famous hoodoo. I think it might be the only, or one of the only hoodoos that actually has a name. This is Thor's hammer, for this little hammer on top. But you notice this rock is eroding slower than the rock below. So again, each one of these layers is a history in time. It could be a million years where the temperature was slightly warmer, slightly cooler, there's more flow and current in the lake. And so life flourished, life was born and died at a different rate, creating different layers of sedimentation as that stuff, you know, basically goes through the water column and settles on the bottom of the lake. Really, really interesting stuff. So, you know, fast forward to modern day, life is still flourishing in the area. All these minerals, all the iron in this red flows out, and it creates a relatively rich environment in an otherwise somewhat inhospitable desert. And life has found a way. There's trees, there's water flows, there's washes, there's canyons, there's this little guy, the regal named golden mantled ground squirrel. Looks like a chipmunk, but is not. We've got pronghorn, we have mule deer, we have all sorts of stuff. So it's really neat, the evolution of these rocks in the area. And I wanted to come back to this. We're at the cliff edge. They also have what's known as walking trees. You can see here, we're really seeing it in somewhat real time, how as that cliffside edge erodes away at that rate of 2 to 4 feet per century, the trees are having to adapt as well. And they're holding fast, they're digging those roots down even deeper. But soil, again, once was here, it has since eroded away through a very, very gradual process of erosion. So quite the neat place, quite the beautiful place. It's you know, easily one of my favorite places in the world. We're moving on. So again, back to Colorado Plateau, we were right here. So imagine yourself going down here along this grand staircase, and we're kind of coming over to this area now. So by the way the crow flies, it's not far at all. We're probably a couple hours away. So as a result, it makes for a great itinerary because we can just kind of center in this region right here and see so much different stuff. Towards the end of the presentation, I'm going to bop on over here and show you some stuff from Arches and Canyonlands too, and kind of round the presentation out with that. But we're really staying here the whole time. But wow, wait till you see the difference. So again, from that sideways schematic, the grand staircase, we were here at the top, so this left side. We're coming down, we're dropping in elevation, we're going through a few different layers. Some of it we're seeing from the cliffside, some of it we're really not because it's covered in vegetation. But we're entering this chasm here, otherwise known as Zion Canyon National Park. And we're going to the very, very bottom of it into a lot of different layers. So when I say there's that 2,000 to 3,000 feet of Jurassic sandstone, we're seeing all this stuff as we're at the bottom looking up towards the top of Zion National Park. Okay, so how in the world did Zion get there? Totally different process. So Bryce is very unique, Zion's very unique, Grand Canyon's very unique as well. But basically what we're at here is we're looking at the top of this chart. Most of Zion was laid down in the Jurassic, Triassic, Cretaceous era, probably more like Jurassic, Triassic, so like that 160 to 200 million years ago. Remember, life is flourishing, dinosaurs are around. This area can still be a great place to find dinosaur fossils. But what we're seeing here, right around 230, 180, 140 million years, Zion Park is right here. So pay no attention to this red star. This is just the map I had to use. I think that's probably like DC, Washington, DC. But basically, Zion National Park and this whole area around this time, actually the whole Colorado Plateau was a coastal area. It was a coastal floodplain. It was sandy, it was beachy. It was also, as you look at this map, it was also right around the equator. So you had warm, shallow tropical seas. When you hear warm, shallow tropical seas, you're thinking a lot of life and birth. Remember, the whole way that all this limestone or sand or whatever forms is from things like seashells, from coral reefs. So life has to be born for it to create sedimentation via coral reef skeletons, et cetera, fish bones, and they precipitate out, they go on the bottom. Then, as you see from this previous map, it starts to more and more accretion, like more of these Pacific islands get slammed into the coast from that, remember that subduction thing I was talking about? So the whole plate that holds the Pacific Ocean is going underneath North America. So it's slamming all these islands in the coast and gradually becomes interior. It also gradually shifts north. So this is a highly technical slide. I'm not going to talk about every facet of this, but basically the long and the short, and you may know this, they're known as the trade winds oftentimes, is right around 30 degrees north and 30 degrees south, you get this area of really high wind and dry wind. So what happens is what started off as a very sandy coastal floodplain gradually moved as these plate tectonics moved the North American continent northward, and it settled, and obviously this map doesn't show the North American continent, but it settled right around 30 degrees north and it got really, really windy. And so what basically Zion National Park started as is a massive sand dune sea that most people agree was probably bigger than the Sahara Desert at its time. Now that did not last forever. It lasted tens of millions of years, which seems like a long time, but life goes on, life shifts. What happened is those sand dunes lithified. They turned into rock, and they were basically preserved for all of time. So this is what we look at when we see Zion National Park today, and you really do get a sense, you get this feeling like, yeah, it was totally a big sand dune, or many sand dunes. Imagine Namibia, imagine some smaller sand dunes areas you've been to in the US, or if you've been to the Sahara. It has that feel, that undulation, the color of the stone, the color of the rock. It also has this idea of cross bedding, which is really interesting. I love talking about this on the trip. Basically, what happens is you can predict the wind direction because of the way these cross-bedding plains were laid down. So what happens is you have some sort of dune, imagine a sand dune, you have wind coming from this direction, it's blowing sand. If you've ever been in sand dunes, you know it's not the place to take a camera out because it's just, there's so much sand particles flying around. You usually have to wear glasses and stuff. So anyway, sand is always blowing, and it's blowing over the tops of the dunes, and gradually it forms just like a cornice. If you're a snow skier, cornice, accumulation of the sand particles, and gradually it falls over and goes on the protected side, the leeward side, and it falls into these lenses, basically these layers. So if we go back to this photo, the direction that this cross-bedding formation is pointing is essentially the direction the sand was blowing at one time. And you can kind of look at all this and get, yeah, these are pointed in this direction to the right. And you can say, yeah, absolutely, that's because it was coming from the west, coming from the Pacific, and boom, it's sort of detective work to figure out what was happening 160 million years ago. Of course, since then, there's been a lot of movement. Now, when I say, the Colorado Plateau is a contiguous piece of rock that has resisted geological forces, it can't resist all of them. It resists the major ones, like big mountain building. It resists the major earthquakes, but it still gets fractures. It still gets uplift. It still gets a little thing here and there, a little wobbly. So you can see this massive sand dune sea that over millions of years was formed, dried out, turned into rock because of pressure on top of it, other layers on top of stone, like maybe the Claron formation, like that Bryce formation, pressing it down, compressing it, turning into rock. It gets uplifted and turned, but you can see it still stays in these cross-bedding lenses or cross-bedding lines. It's really, really beautiful. So again, it's hard to say which I like better, Bryce or Zion, but they're just so gorgeous. This is the kind of place I could stay for days and days and days, so it's always a treat to visit it. It's really quite pristine. So the eastern side is very typified by these big vistas, these big views. You can see here they also have capstones here. It's eroding slower, it's protecting the rock underneath it. And again, yeah, a lot of this was laid down during the times of dinosaurs, so there probably are still dinosaur fossils we found. The west side, although, is a little bit different, and this is the classic Zion that we think about, and it's all due, well, of course, the same deposition, the same layering happened to this entire region, but you have this act of a little river known as the Virgin River. It flows at about, I think, 160 cubic feet a second, which is like not a big river, not real fast. Compare that with the Grand Canyon, that's like 20,000. It's very, very slow, but nevertheless, water has this amazing power to have carved out all this rock. Everything you see, all the sky, all the left, all the right, was carved by this little river. Now, it's not carved by the river at its lowest state. It's probably, it's carved at a much, much faster rate when there are flash floods, when there are thunderstorms. At the end of the last ice age, you have an uptick in rain. So this river was certainly bigger at one time, but nevertheless, it's really cool to see it still having erosive properties with just what is kind of like a stream. Every 10 years, some massive boulder blocks the road or blocks one of the trails. It usually happens in a rainstorm when the trails are closed anyway, but things are still happening. It's a very dynamic place. So we're looking at the Virgin River from a different angle here. And one of my favorite places to really observe and enjoy the Virgin River is in the Narrows. And this is a very, very iconic hike I love to get to. This is where you see the sheer rock cliffs on either side. They go up 2,000 to 3,000 feet on either side. Incredible light. You can actually walk in the water. We get you special boots, and you can walk over rocks and hiking poles and all that, little neoprene booties in case it's a little bit chilly. It's really cool. And, again, I think it's, I say this a lot, but it's like one of the most beautiful places in the planet. So I love the contrast of Bryce to Zion, because what we do is we spend some time on top of these amphitheaters in Bryce, on top of the canyon, looking down. In Zion, you're always at the base. You're always down looking up, and it's so, so impressive. It's so massive to be looking up these massive towers and having access to this river and all the beautiful trails and whatnot that surrounds it. You can see here some exposed rock here. Hiking trails are fantastic. You can see a little bit more of that slanted rock, et cetera, et cetera. And wildlife is pretty good too. So again, as these sediments flow down the river, as minerals become exposed, plants have habitat, they can take hold in the sandy soil, wildlife come to eat the plants, and one of my favorite critters in the area, these desert adapted bighorn sheep, you can be found pretty much year round, get some astonishingly close views. They usually come up to you, they'll sneak up behind you. Not dangerous, but in a fun photographic sort of way. But then, sometimes we're seeing them from afar, maybe using spotting scopes or binoculars. But either way, they are certainly one of the denizens of Zion National Park. And just sort of an ending photo here of the Narrows. And I was going to mention this in an earlier photo that had a little bit better visual of it, but I'm going to kind of illustrate it here. This is another recurrent theme throughout this whole area and throughout like the geologic process of erosion via water, is that you think, oh gosh, how in the world is water going through like 2,000 or 3,000 feet of sandstone? Well, it certainly does slowly but surely, but one of the big things it does is known as down cutting, and you can kind of see it in the distance here where that rock clefts under a little bit. So a lot of this rock is not exposed to water all day, every day, but a lot of it below the surface, of course, is. And so what happens is as that water steadily carves below the surface, it exposes rock above. So it cuts into the rock below, and it has this overhang. And eventually that overhang is going to get too heavy to support itself, and it's going to fall off. And that can create these massive rock slides that Zion is known for, usually after big 100-year rainstorms, et cetera, et cetera. So really, if we step back and think about it, it's not just this little trickle of a stream that's just steadily taking one particle at a time. It's really the water going through the rock, eroding it enough that it undercuts and it topples down in sort of big, magnanimous way. Okay, so I love Zion. It's fantastic. We are in this park here. So remember, we started here. We're over here now. Now we're going down into northern Arizona. One of the last big parks I'm going to talk about before I do a quick little cameo for a couple other favorite areas in the region. But North Rim and South Rim of the Grand Canyon. And I'm really pleased to say we just announced, I'm not sure if I think it's official now, we just announced another itinerary to the canyons area that incorporates south rim of the Grand Canyon, which is, I believe, a first for us, and it's really, really exciting stuff. So just to go back to this grand staircase photo or image illustration, we're in Zion here, we're traveling here, we're going all over here, we're going over the chocolate cliffs. It sounds delicious. It's not really like the Willy Wonka chocolate factory thing you're thinking of. It's just a different color rock. It's a little bit more iron in the soil, but nevertheless, we go over the chocolate cliffs, go around the gumdrop lane, and then we come to the top of this big ditch right here, north rim of the Grand Canyon. Now, what happened, I'm not going to go too much into this, but remember these small processes underneath all this, when there is a little bit of disturbance below all the rock, they can push up areas like this magma just has a big plume that pushes up rock. So what happens is form this thing called the Kaibab Plateau. And it's actually made elevation-wise the Grand Canyon about the same height as Bryce over here in Cedar Breaks. So we're at about 8,000 or 9,000 feet, another great dark sky area of the world. But the really cool thing is that we have this exposure to about 1.5 billion years worth of rock. Okay, so the other cool thing, we saw these charts before, all of the stuff that happened in the Grand Canyon actually predates everything we saw here. In fact, the way the world looked when the Grand Canyon's soil, all the soil around it, all that rock was laid down initially, was back when it was a big, big ocean on Earth. Quite different around, 1 billion to 600 million years ago. So this all happened underneath the ocean, all happened underneath the sea. And the Grand Canyon, through history, was actually over and underwater about 6 different times. So the water would come over, it's an ocean, sedimentation, rock layering, more layers. It go away, dries out. Ocean again, more layers, goes away, dries out. And gradually, again, we're getting through this entire period. We're looking at rock that was all in this time period. So the fossils that we do see in the rock are usually like weird little trilobites and isopods and things that look like horseshoe crabs. It's pretty amazing, but it gives us a really, really good look at what life might have looked like way back in the day, way before the dinosaurs, before the largest extinction event on the planet, the Permian Extinction. So yeah, quite an old book for Grand Canyon. You can see here exactly what I'm talking about. Like every single one of these layers is a different period of time. It signifies different atmospheric conditions, different oceanic conditions. Remember, the whole time that this is forming over the course of 1.5 billion years, all these continents, all these plates are moving. If you were to fast forward like a time lapse of 1.5 billion years, it would just be moving around like a swarm of ants all over the earth. It's pretty amazing. But nevertheless, this is the pages of stone that we're talking about. We're looking at a lot of different stuff. So this is probably one of the more colorful formations because we're talking about such a big period in time. When we look at Bryce, we're talking about, that whole formation in the matter of tens of millions of years. When we're looking at Zion, we're looking at, again, kind of tens of millions of years, but Grand Canyon, hundreds of millions. So this entire group here might have been laid down while, the same amount of time that Zion was forming. So it's a huge amount of rock. It's about a mile deep, but believe it or not, based on looking at rock that's on the surface of the earth, geologists and scientists of today have figured out that the rock that's currently exposed at one point was 6 miles below the surface. That means at one point there was 6 more miles of this rock on top of everything we're seeing in the Grand Canyon that's all been eroded away. So remember, like the interesting thing, is that we're seeing one snippet, one slice of time. At one point, this looked entirely different. At one point, there were 6 more miles of rock on top. Who knows what it looked like? The other interesting thing is that the Grand Canyon itself is not that old. The Colorado, which flows through it, most people estimate that it's only been flowing for about 6 million years, which is not a long time. That's not a long time for so many layers of rock, so many millions and billions of years of Earth's history being eroded and exposed. But it's because this river is raging. Like I said, it's 20,000 cubic feet per second. It's massive. We're talking about erosion happening at a light speed pace. There's a stat that the Colorado River can carry about 500,000 tons of rock and debris, roughly eroding about 1 inch every 100 years. That's pretty amazing. Every single day, 500,000 tons of rock is removed via the Colorado River from the Grand Canyon. That's a lot. You look down there and you see it raging, you see people river rafting down there, and it's a pretty active space. So when we look at North Rim here, we got the corner of Utah, Nevada, Arizona. We're here. South Rim is right here. So we're kind of seeing roughly the same area, but remember that tilt makes the two areas quite different. This North Rim is about 8,000 or 9,000 feet. South Rim is at about 6,000 feet. They do connect via the Bright Angel Trail. You can go to Phantom Ranch and access the river. Some people even do ultra running trips that go down and up in the same day, et cetera, et cetera. But yeah, lots of amazing, amazing views. I love both areas, both rims. The North Rim is a little bit more secluded. It's a little bit harder to get to. So South Rim has a little bit of an advantage with access points, with more extensive trail networks, et cetera, but it is a little bit more busy. But if you were to ask me to name, my favorite at this point in time, both rims are pretty fantastic. They have different merits indeed. So you can see here, it kind of just blows away your imagination. You've been in Bryce, you've been in Zion, you've seen some really cool things, very different formations. Grand Canyon is all about this immensity. It's all about this extraordinary amount of time that this rock has been on Earth. A couple of my favorite viewpoints. A couple of my favorite sunrises and sunsets on the North Rim here and South Rim. So as this stuff erodes, we're going to talk about the wildlife here as well. A really interesting wildlife story of Grand Canyon is the rescue or rehabilitation of the California condor in the area. And I love that we actually have a pretty good chance of seeing it from both rims, whether it's the North Rim or the South Rim. There are a couple hundred of these guys currently living and I would like to say thriving in the area. There are certainly conservation concerns that we'll talk about, if you join me on the trip, or we can talk later, maybe one of the questions. But nevertheless, the California condor is indeed making a comeback. You can see one of the little radio collars. I believe all of them have some sort of marking device on them. They either have something on their wing that shows the number or actual GPS or VF transmitter here. So yeah, getting a view of these with their massive 9-10 foot wingspan is pretty darn amazing. Found on the Kaibab Plateau almost exclusively. Another thing that's found in these beautiful meadows in the Kaibab Plateau is another thing that's only found here, the Kaibab squirrel. And I often joke with my groups that, this is probably the most special animal we're going to see over the course of the trip, just because of how isolated its range is. It's only found in this small little area of the North Rim of the Grand Canyon. You can see it's quite a striking squirrel. I had to pick this from online, but I just really wanted to get this one to show you that amazing, amazing white tail and the tufted ears. Quite a beautiful little critter. So life will find a way, no matter how long it takes to get there, no matter how desolate it may be, life will find a way. And I think that's a really great take-home point when we talk about the biology of some of these areas. So before we do dive into Q&A, I wanted to go over a couple areas, principally this area on the more central part of it, eastern Utah. One thing I'm really excited about that's added into our South Rim itinerary is a chance to visit Horseshoe Bend. And this is a really, really famous area. You can see here, it's always difficult to get a sense of scale. You can see here, these are some boats down here. You can imagine just how big this area is. It's really, really massive. And this is a formation in Page, Arizona. So when you get through the rest of the Colorado Plateau with those, 18 different monuments and 9 different national parks, you get a pretty massive area, an extraordinarily diverse landscape. Some of them are kind of just like roadside quick stops. You look at it and that's it. There's no hiking trails. Others are just massive trips in themselves. And I'm hoping that we can put together sort of like a second canyons itinerary that does the Moab area, does places like Canyonlands here and Arches, because they're simply sensational. If you are joining us on a trip, or if you have plans, it's absolutely worth getting a car and doing this on your own. It's very, very easy to get around, and it just offers an entirely different view. I love it because you can look at the La Salle mountain range here. It's a very, very different view. And of course, the arches are pretty spectacular. So for the rest of the presentation, it's only just a few more minutes. I want to talk quickly about how arches are formed. It's a question I often get. We'll see small little arches in those other areas I was just talking about, whether it's an arch just starting to form on a rock wall, or maybe a smaller one on one of the hiking trails. But when we think about, the big arches of North America, the big arches of the U.S. national parks, we think the actual Arches National Park. So the first thing people often think about is, well, okay, how in the world is an arch made? So people might often think that this is how arches are made. This is a way, but this is also known as a gooseneck. It's not a real proper arch. And what's happening here is you get a river, it's flowing around here. This is kind of how oxbow lakes are formed as well. and eventually that water punches through. So it punches through this rock wall just by sheer force and sheer determination, and gradually over, again, thousands, millions of years, it erodes into this arch form. However, this is not the way the arches were formed in Arches National Park. This is more of like a gooseneck, as it's called. There are goosenecks around the region, but the way I like to retool that phrase is it's not so much how arches are made, but how arches remain. So I like this graphic here, and this kind of gives us a good view, a little bit textbooky, but what we see, so if you remember back to that original tectonic plate chart where we have the Pacific plate and the North American plate, what's happening essentially is throughout millions and millions of years, that Pacific plate was rotating a little bit because of that small little rubber ducky plate. I don't know if you remember, known as the Juan de Fuca. So it's rotating because of friction, and what that does is it's actually stretched out the continental crust. So as it's rotating, what happens when it rotates, you get all these fractures. So like in between my fingers here, they start to fracture as you get this friction north to south. So the really amazing thing is that as these fractures start to form, you get a little bit of rain down in here, you get a little bit of frost wedging, you get a little bit of acidification, so slightly acid rain, nothing that we could even feel or anything, but over millions of years, that slightly acidic property of the water erodes to the rock a little bit more. And the big thing is as it goes through this rock, arches remain. Well, why is that? Now, again, I could probably talk for a whole another hour about this, but the very basic gist is that as you see arches, it's very similar to like how a Roman aqueduct might work, or why you see arches and bridges. Is an arch is sort of like the most stable structure, because what happens is all the weight that's put down on it is very uniformly, very equally distributed at the tangent of every like force point. We're kind of getting into weird calculus stuff here, but the long and the short is that the arch is kind of the most stable, sturdy structure in the world when you're dealing with top-down weight and top-down pressure. So as these rocks erode away, the arch is simply just the most stable form that is the last thing to erode away. It's not like this arch is some weird intrusion of like volcanic lava and it's really, really sturdy. It's just eroding slightly slower than the rest of the sandstone around it. It will eventually go away. I mean, some of these arches might topple over in the next couple hundred years. Like this is delicate arch. It might truly be one that we see in our lifetimes. But the other interesting thing is that if you notice and you look at Arches National Park, every single arch is along that north-south orientation because of these fractures, these small little fault lines from the rotation of the cliffs. And so another picture here, you can actually just go on Google Earth and look at this, is notice how all these different, we call them fins, are actually long views of the arches. The arches are in between all these. So it kind of distills it down to this really interesting takeaway that, basically arches are the strongest rock structure. They simply remain as the last thing to erode, and we happen to be living on Earth at the right moment to see them in all their glory and beauty. So other quick thing I want to mention here, a really fascinating way water erodes the Southwest deserts is via slot canyons. So I'm just going to show a couple cool photos here. I often get questions about these. This is a very special type of sandstone, a very, very soft one, and it erodes through these flash flood slot canyons. And when you get down in there, it's not that the rock is actually this color, but the way that the light bounces off within the rock with a slight hue of yellow and oranges and reds, all from iron essentially in the rock, forms these amazing slot canyons. And I want to go back to that photo here because when you do get a chance to view one of these slot canyons, it's the most wonderfully unassuming thing, because the trail is going to start off like this and you're just going to go down in here, and all of a sudden out of nowhere you descend into this prismatic wonderland of color and light and rock. And it's pretty special stuff. So I'd be remiss if I didn't mention at least a little bit about slot canyons, but with that we pretty much are at time. I want to save time for questions, and I'm sure I have some great ones out there. So Kendall, what do you got for me?
Thank you, Court. Before we get to the Q&A, I just want to remind everyone watching, if you have a question for Court, you can submit those in your control panel under the questions field. All right, first question. Do most arches have a capstone that protects its top from erosion and fracture?
Oh, that's a good question. I mean, I wouldn't say most. Some certainly do, but usually no, it's not. It's a relatively contiguous piece. Now you'll notice that there are slight differences. Like even if I go back here, you'll notice that like see how there's a weaker point here. This is all This is all laid down through probably tens and hundreds of thousands of years and maybe even millions. And what happens, again, because everything's being laid down in marine environments, you get, an area or an era, a time period where, that sedimentation is a little bit looser, a little bit thicker, or maybe those marine organisms are really, really hard shelled or really soft shelled. So you do often get capstones on top, but usually there has to be some sort of differential erosion. Usually it's just the straight up, rock structure that's melting away. Capstones are there, capstones are not there. It's not a requisite necessarily.
Okay. And how does the continual seepage of salt into areas such as the Paradox Valley contribute to erosion?
Oh, that's a good question. I might not know the answer to that, but let's kind of think about that for a second. So the continuous seepage of salt. So obviously there's salt in these rocks. It's a marine environment. I would say, as soon as you add salt into things, you're definitely changing some of the chemistry. I would imagine it certainly would change the composition of the rock. I think it's I'm not a geologist, so I don't know if I can say it would definitely erode faster or slower. You do get a different chemical in there. Yeah, that's a good one. I might have to say I don't totally know the answer to that, but great question.
Yeah. So I'm guessing this question is about going back to the hoodoos. Do the caps ever fall off, making it dangerous to walk through there?
No, I mean, short answer, like they can, but so here's the thing is that anytime you're in areas like this, I mean, people have been studying and traveling there for many, many, many decades, and they know that when you get a big heavy rainstorm, which is very infrequent, you just keep people off the trails. Like the trails will literally be closed if you get a thunderstorm to come through there. Fortunately, that happens only like a couple times a year, truly. So yeah, we wouldn't want to be hiking under one of those big capstones in a really torrential rain because you can't just like from a distance look at them and say, "Ooh, that one's going to go any day now." So we want to play it safe. And with any sort of erosion, it doesn't have to be a capstone. It could just be like a big slough off of rock. Remember, these things are so big that it wouldn't take much rock to be dangerous. So the big thing is just to not hike out there when you get a big torrential rain.
Hmm. So this is for the slot canyons. How long does it take to walk to get to one from where you park your car?
Yeah, so fortunately there are a lot of them out there in the Southwest deserts. I would venture to say the majority are still undiscovered. So you could be walking years and not find, but no, in truth, like the more well-known ones, usually there are a couple in Page, Arizona that are definitely on the radar. They are part of the Navajo reservations. And they do have like a ticket counter and a gate and a parking lot, and it's like a 2-minute walk, and then the whole slot canyon that you've probably seen, like most photos of like those crazy colorful slot canyons are from like maybe 1, 2, or 3 different slot canyons in the area. That whole walk is like a 1/4 mile. So all those different views, all those different colors, all those different angles, it's all in a very, very small amount of area. And I think that's a big reason why so many are undiscovered. But those that are known, it's all across the board. I would say Lower Antelope in Page, Arizona is the most well known, but you can go down to Buckskin Gulch. You can find a lot of slot canyons, bigger slot canyons in Zion that might take you a couple miles. And there's a whole industry of canyoneering where people are actually out there trying to maybe not discover new slot canyons, but finding the ones that are, barely in the guidebook. And they have all their safety gear, they have all their ropes, all their protective gear. Sometimes they'll even, take oxygen, or they'll take inflatables, they'll take rafts just to see how far they can get. So if you want to get out there, you can get way out there, but there is a way to see some a lot closer to the car, so to speak.
Okay, great. So on a Nat Hab Canyon strip, is there plenty of time for hiking, and are they guided hikes?
No, we don't like hike. No, of course, that's the whole trip. Yeah, absolutely. There's plenty of time. I think there's plenty of time. I know all the expedition leaders on those trips, and we prioritize getting out there. If it's something where we're pushing the envelope and doing more than some people in the group might not want to do, that's why we have a couple different expedition leaders, and we'll do side little hikes. We'll do different options for the day. So yeah, I mean, pretty much any day that is not like a travel day, we're doing a really great hike or a really great drive and viewpoints in the morning, and then another one in the afternoon, where we might have great sunrises or sunsets. We might even do 2 more, so like a quick little sunrise hike, then a proper morning activity, proper afternoon activity, and then maybe even like a quick sunset hike. We like to provide as many options as possible. You know, burn the candle at both ends if you can. You know, it's a power pack trip. You know, if we're looking at 7 or 8 days, we probably fit in what you could do on your own in like 14, just because we know when and how to do all these things in an efficient way. But we also get out there and we do spend a lot of time. That all being said, the hikes that we do, they are not like 5-hour hikes. You know, they're like a couple miles at a time. Some of the viewpoints might be, you know, a quarter mile or half a mile, but you know, that's the beautiful thing about these national parks and monuments is that you don't necessarily have to do the super long hike. Kind of getting back to your question before about the slot canyons, there are some pretty extraordinary things to be seen. Short hikes from the quote unquote parking lot, short hikes from the lodges. But of course, because we want to get out there, we like the sun, we like the everything and the hiking. We do get out there for, you know, a couple hours each morning, a couple hours each afternoon. And yeah, I think it's a great experience.
Okay, great. So what do you consider the best time of year to visit all these places you were just discussing?
That's a great question. So, um, arches aside, that's a little bit different. That kind of like opens the window more. So the Bryce Zion Grand Canyon, you basically have the spring, summer, and fall. Winter, you actually get a decent bit of snow in Bryce. They don't really plow it. You wouldn't necessarily want to be walking in snow the whole time. Grand Canyon, Northern at least, is physically closed from like middle of October to middle of April. So really, to me, the big question is spring, summer, or fall. Summer, you know, I think is great if that's the only time of year you can go. I think there's a little bit better chance to get out there and have fewer people around you in spring or fall. And then it's really a question of kind of your hot cold tolerance. If you are a person that deals better with cold and doesn't like the heat so much, I would go in the spring. You might get temperatures in the 40s first thing in the morning if you were to walk out and do sunrise at Bryce. But then flip that, in the fall, you will have, you know, you won't get those freezing temperatures or close to it, but you might have some pretty hot days that get into like the 90s, whereas in the spring, you're really never getting above like 70s or 80s. That all being said, there are pretty, you know, pronounced differences between Bryce, Zion, and Grand Canyon. Bryce and Zion, you know, are usually lows around 40, highs around 70. Zion being so much lower, about 4,400 feet, you're looking at lows around, you know, probably 50, 60, and then highs around 80 or 90. And then basically go to that upper range for fall. What I just gave you was kind of like the springtime. Fall is just generally warmer, so you don't get the cold temperatures, but you might have a little bit of heat to contend with.
All right. So for this last question, I might be putting you on the spot here a little bit, but can you recommend a good book for non-geologists, just a nice basic book that runs through all of this?
Yeah, no, I definitely can. Actually, you know what? I think one of the books I got in the either the subtitle or some part of the title is Pages of Stone. It's a little bit more geology. Like it probably, now that I think about it, it's a really great surface level cursory overview of a lot. It might not be the most like pleasure reading. There's other great books if you, I guess this is kind of getting into the nerdy geology part, that are like, they're like driving guides for geology, in both, or not both, but Arizona, Utah, and Colorado have those. And basically it points out every mile marker on every highway. It says, hey, you see that stack of rocks over there? This is exactly how it happened. That's pretty in depth. You know, some of the best books are actually at the U.S. National Park stores, and they're very thin. They're very, you know, heavily photo centric. I would think that they're probably online. Um, you know, frankly, yeah, I'm not sure if I can name anything other than those really detailed ones because, you know, I'm a nerd and I like those. I like the really in-depth stuff. But um, yeah, actually, I guess you are putting me on the spot. I can't name one that is like a really great narrative. Um, yeah, sorry. If I think of it, maybe we can get back to you on that one. But great question. I you know, applaud you for wanting to get more into it. You know, I'd say the best way to learn about it is, you know, try to get yourself out there. There's certainly, if you are joining a NatHab trip or some other guided trip out there, in general, there's no need to prep ahead of time. You can come straight to the test without studying. we go, it's just great to be out in the field and actually seeing this stuff. And you're like, oh yeah, look at that layer right now. Like that's definitely where like the T-Rex was roaming the earth, et cetera, et cetera. This is when the water came to the shore, et cetera, all that stuff. So yeah, learn by seeing and doing is always fun too.
All right, thank you, Court. Well, this was really, really fun. Thank you so much for taking the time to present for us. I'm going to hand it back over to you for closing comments.
My pleasure. Well, guys, happy holidays. I wish you the best, and I wish you, if I don't see you guys before the new year, a very happy new year. Cheers to 2021, the best year yet, right? So hopefully you enjoyed the presentation, saw some cool photos, some things you might like to visit or have visited and had some great memories and times there. And yeah, cheers, guys.
Thanks again, Court. And my thanks as well to everyone who tuned in today. Be sure to join us tomorrow for our next Daily Dose of Nature. We did record today's presentation, so we'll have the replay available on our website soon. And with that, I'll conclude the webinar. Goodbye, everybody.